Good morning, and once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want to introduce something on Pure Mathematics 4, Pure Mathematics 4, topic number topic number 4, which is binomial expansion, and I want to discuss something to do with expanding a plus bx raised to power n. And we are saying that the binomial expansion of 1 plus bx raised to power n can be used to expand. It can be used to expand a plus bx raised to power n. And how can this be achieved? For any constants of a and b. So you need to factor out a raised to power n out of the expression, and we have it like anytime we have a plus bx raised to power n, it must be seen by everybody there is a that is a factor 1 plus b over a x raised to power n, and as such the bracket is the n rather affect including the a, so we can easily write this one in terms of a raised to power n separately multiplied by 1 plus b over ax raised to power n, and that can just be the expansion we're looking for. It must be compared with the following. Of course, when we have 1 plus b raised to power n compared or rather versus a n 1 plus b over ax raised to power n, this is bx, we're saying that this expansion is valid when bx is less than 1. And of course, every time we're talking of that, then we talking about when x itself modulus is 1 over b is less than 1 over b. So in the same kind of observation, you realize that since this is 1 plus bx and this is 1 plus b over ax, it is valid. This expansion is valid when b over ax modulus is less than 1. And of course, if you would want now to make x the subject of the formula, it follows that you multiply by a over b, which is talking about the modulus of x is less than a over b. That one should not escape anybody's mind. So even as we look at example 6, please take note of that. In example 6, we are told that example 6 part A, find the first 4 terms in the binomial a 4 plus x and the root of that. Everybody knows that this one is the same as 4 plus x raised to power a half. And having said that, you can see that a is not equals to 1, so we have 4 raised to power n open bracket 1 plus x over 4 close bracket raised to power n, as we have just expressed up there. We have used this approach to get to this particular point. So of course you all know that the square root of 4 is 2, so this is 2 open bracket 1 plus x over 4 raised to power half, and it is this part that we must expand into 1 into 1 plus nx, and x happens to be x over 4 plus n minus 1, which is minus a half, and then x over 4 squared over 2 factorial over 2 factorial, that is the third term, plus n minus 1, n minus 2, x over 4 cubed over 3 factorial. So if you look at that, it gives us, of course, this is an expansion of this particular part. This is an expansion of this particular part of the binomial. So essentially, everything here is supposed to be multiplied, by 2. So everything there is supposed to be actually multiplied by 2. So we need now to take charge and bring the solution here, which is going to be 2, open a major bracket. We have 1, of course, minus x over 8 or plus x over 8 here. This is x over 8 plus x over 8. That is the second term. The third term, minus 1 over 4, because a half times minus a half is minus 1 over 4. Minus 1 over 4 times x squared over 16. Times x squared over 16. We're going to have minus 1 over 4. This is going to be negative 1 over 4 x squared over 16, which is everything is going to be over 2. Let us simplify that part. But before we simplify that part, probably we can go to the fourth term, which is going to be a half times minus a half is minus 1 over 4 times minus 3. This is already, this is 3 over 8, and we can talk about as 3 over 8, and then x cubed over what? Over 64, because 4 cubed is 64. So we have that, everything over 6, and then we can close there. So it is our duty now to simplify on what we are having. So we are having 2, 1 plus x over 8. We have no fight about that. But you can see minus 16, 16 times 4. 16 times 4. What is 16 times 4? 16 is 64. 64 times a half is minus x squared divided by 2 is x squared over 64 times a half is x squared minus x squared over 128. What of this? This is going to be 3. Is going to be 3 over 64 times 8. Let's talk about that. Let us see what is 64 times 8, which is 512. 512 times, this is going to be 3, this part alone is going to be plus 3 over 512 x cubed times 1 over 6, because we are dividing everything by 6. Now dividing by a number means multiplying by its reciprocal. So already we have, let's talk about 3 all over 512 times 1 all over 6, and let's see what that gives us. It's going to give us 1 over 1024. So it's going to be the whole of this is going to be, the whole of this now becomes 1 over 10 24x cubed. So eventually you're going to have 2 open brackets 1 plus ax over 8 minus x squared over 128 plus x cubed all over 10 24 close. And of course we need to open up and multiply everything by 2. So at the end of the day we're going to have 2 plus x over 4 minus x squared over 64 plus x cubed out of 512. And that is it. Plus, we can go on, but these are 4 terms, 1, 2, 3, 4. And what is, state the range of values for x for which each of these expansion is valid. We had talked about validity, and we said that it is valid when in case of such an expansion, this expansion, it is valid when b over a modulus x is less than 1. And in this case we had an expansion that that was starting like 4 plus x raised to power a half, and our a is 4 and our b is 1. So it is valid, this is valid when b, which is 1, over a, which is 4, x modulus is less than 1. And if you cross multiply everything, you'll realize that it is valid when the modulus of x is less than 4. And that is just like it. So be on the lookout for example 6 part B and apply the same. This is when the power of the value of n was a fraction, and we might be getting the value of n as a negative number in part B of example 6. All right, please get to my YouTube channel, subscribe and share widely, and let us help each other.